Good afternoon, everyone. I'd like to thank you for joining us for UMBC's GIS Now webinar. I'm Dr. Erwin Villiger, Director of UMBC's Master of Professional Studies in GIS. For those of you that are not familiar with the MPS in Geographic Information Systems, it is an evening and hybrid online program located in Rockville, Maryland, designed for those that need a more technical understanding of GIS. We focus on the system side of GIS by concentrating on application development, spatial database development, web development and services, and advanced analytics and visualization. If you feel like you need to advance your technical skills, check out our program. We have a full master's degree, but also a graduate certificate, and we are currently developing advanced graduate certificates in focused areas for those with a solid GIS background. Have a look at our website or contact me for more information about the program. This webinar series seeks to provide insight to goings-on in the geospatial industry, to look at innovative new applications and technologies, and to highlight topics that are relevant to GIS professionals. Our webinar topic today is on the application of near-repeat analysis to two urban housing issues. Near-repeat analysis is an emerging spatial approach to analyzing event data in a spatiotemporal context. It has seen increasing interest and application in crime analysis, but has much broader applicability to spatial social science that has not been fully explored. Please welcome Ron Wilson, our speaker today. Ron Wilson is a social science analyst in the Office of Policy Development and Research with the Department of Housing and Urban Development, and has been the program lead for spatial analytics here at UMBC's MPS and GIS at Shady Grove since its founding in 2008. Previously, Ron directed the Mapping and Analysis for Public Safety, or MAPS program, at the National Institute of Justice, and was instrumental in expanding the use of spatial analysis and other geographical methods in the field of criminology and law enforcement. If you have questions during the presentation, please feel free to post them in the question panel in the webinar app. We will collect those and have them addressed at the end of the session. I'll now pass the mic over to Ron Wilson so we can get started.
Well, thank you very much, Erwin. I think you pretty much covered. Thank you very much, Erwin. I think that pretty much covers everything as far as the introductions to me and the near-repeat analysis. So since I've got a number of things to show, I'm going to jump right into it. I am going to show two examples with the near-repeat analysis approach for measuring urban and housing problems. The first one is going to be looking at the spread of foreclosures with an example of how you can use that for investigative strategies for mortgage fraud and predatory lending. I'm also going to show it how to measure for the potential concentration of voucher holders across the space and time. So a little bit of background from the near-repeat expectation. As Erwin had mentioned, this is an emerging approach in criminology. Started some time ago with repeat victimization from a man named Peace from the UK, and has been growing quite rapidly in the use of spatial analysis in criminology, particularly some folks from the University College London and the criminology department from Temple University, who have been doing a lot of research in this area. In particular, I'm going to be showing a software program called the Near Repeat Calculator that extends an original approach by a man named Knox with regards to measuring space-time. So as I'll get into more of that later, but the important thing about near-repeat expectations is that this is founded in geography. It is founded in what's known as the first law of geography, coined by Waldo Tobler some years ago, that things that are closer are more related than those things that are further away. So there's a spatial relationship between events that occur in space. The closer they are, the stronger the relationship that they share between them. The further away they are, the less so. This is sort of founds on the idea of spatial dependence. The near-repeat expectation also employs the theory of spatial heterogeneity, which accounts for geographic variation across the landscape. Not everywhere or every neighborhood or every region or every country is the same as its neighbors, and these things fluctuate across space. So the near repeat expectation is that not only will things that are closer be more related, but that relationship between events will change across space. So the near repeat expectation is that it's applied to location of based events in which there is no reason to expect repeats close in time as well as in space. And I'll get into a little bit more about that as I demonstrate where the near repeat idea came from. Originally, it came from the Knox test, which was a test to measure just simply whether something was in proximity, in space, and time only, where one distance and one time frame was presented in which you have a contingency table here. Along the top axis, the x-axis, you have time, which you have either in proximity or not in proximity. And on the y-axis, you have distance, which is either in proximity or not in proximity, which makes up a contingency table of 4 possible events. And we are going to be measuring with this test whether something occurred both in space and time, because that is what we're really measuring for, to see if something is interacting with something in both space and time. So the near repeat test then, which expands the Knox test a little bit further to add multiple time intervals and multiple distance intervals for which each cell in that contingency table gets the opportunity to be analyzed and tested for a combination of events being in proximity to each other as well as in time. So you can have an unlimited number of cells in here of time intervals as well as distance intervals to allow for the opportunity to test them at any particular one of them. And when we get to the near repeat calculator, you'll be able to see that you can focus in on any one of those cells if there is for any particular reason. So this is what it looks like in more of a graphic, where on the top you have time continuum, for which you have Ti and Ti plus 1 as 2 representative time intervals. And on the bottom you have geographic space, which you have Di as 1 spatial interval and Di plus 1 as the next spatial interval. Well, when they converge together to be measured, they show up in the cells there in the center, whereas you can see event 6 is in time 1 within distance 1. But event 7 is not in time 1, but is in the next time frame. So those two would not be measured together in that particular cell. But if we see that events 2 and events 5 all fall in the first time interval, but are now in the same spatial interval as well, for which those two events will then be measured to test for whether or not they statistically meet significance with interacting in both space and time. And we'll get to how that test occurs here by looking at how the near repeat calculator works in regards to identifying near repeats. The near repeat calculator was invented by Jerry Ratcliffe. He operationalized the idea of near repeats with multiple intervals of time and space into a nice little software package called the near repeat calculator. And if you did a search on that, you would be able to find that, for which a lot of research is going on out there now in criminology. And we're trying to demonstrate it here, and it has lots of applications elsewhere. So basically the idea of near repeats follows a Monte Carlo simulation in which an expected distribution of space-time distance pairs are created. So in this case, what you have is a set of fixed locations in which dates are randomized to analyze, to create a distribution for which to compare an observed set of patterns for. So each one of the dates are randomized up to the specified number of times to create a certain size distribution for which to compare against. So this can be run 19 times for a p-value, a significance level of 0.05, 99 times for a significance value of 0.01, and 999 times for a significance level of 0.001. And so this gives you, the more simulations you run, the larger the distribution that you create, and the more likely that if you find an event pair that meets that significance level, it is likely not due to chance and is a real space-time interaction. So what happens when they're all done is that it creates this distribution off here to the left showing the number of Monte Carlo simulations. And then you compare that with the observed number of pairs that were in your original data set, and you can see for in this example that you have 2,865 observation pairs were found within 660 feet and within 30 days of each other. And that number of observation pairs is very, very far outside of the distribution that was created by the Monte Carlo simulation to give it a very high level of statistical significance, meaning that those pairs in that time and in that space were not likely due to chance. And this prompts people who are analyzing the phenomenon to say, all right, this is something where we have to investigate. There is something causing this convergence of time and space with these events, and we should pay attention to that. And for whatever it is, policy can be enacted, whether in a law enforcement environment for a tactical or policy situation where a local jurisdiction's executive leaders need to respond. So I'm going to give some examples here for the detecting of the spread of foreclosures in Charlotte, North Carolina. So under our near repeat expectation, we would not expect that foreclosures would occur in close proximity to each other in short periods of time. Typically, foreclosures are related to random life-related events and are usually isolated in both space or time. A number of reasons, from divorces, from loss of jobs, from a death of a spouse, to bankruptcy from medical bills, what have you, can lead to a foreclosure for which any family who owns a house could be affected at any particular time and any particular place. So we would not typically expect to see foreclosures occurring in time and space. However, over the last decade, we saw 4 non-mutually exclusive reasons to why we might expect to see foreclosures occur in close space and time. There's a lot of research out there that has been examining this phenomenon and has definitely identified a relationship in space, where a few of them have identified relationships in both time and space. So our job here is to sort of detect that space-time interaction to provide more merit to those research projects that are emerging that are trying to measure time and space. But also, and more importantly, this gives local leaders in jurisdictions who are being hit hard by the foreclosure crisis some more immediate results to take action. Because the near repeat calculator and the near repeat approach will allow you to do an analysis that will give you something with strong statistical significance and allow you to identify foreclosures as they're emerging to try to deal with that particular problem. So those 4 mutually exclusive, non-mutually exclusive events were: there was a large amount of deregulation that allowed a growth in lending practices, and because of that growth, new lending practices emerged with new technologies, with new ways of advertising for new outreach, that started a frenzy of purchasing behavior that caused the markets to rise in prices, and people got into this idea that if they didn't get into a house soon, that they would not be able to, and they were doing whatever they could to get into a house. And with that, you need demand, so urban development patterns were such that housing construction was just being driven by that demand, and all these came together to provide a landscape for which a number of sales could occur, but also a number of people getting into mortgages that they could not afford. So now that we have our foundation there, what could the damage do? Why would we even be concerned about near repeat foreclosures? Well, concentrated foreclosures can have cumulative and long-lasting damage on neighborhoods. There's been a lot of research out there on the damage to neighborhood conditions, the emergence of crime, the loss of tax revenues, the change of neighborhoods that were once thriving to ones that are deteriorated, and you have a situation where you have to stem the tide of these properties that are in decline for a number of reasons. So with the convergence of all those four events, you created a consummation of risky loan geographies. So these geographies weren't created all of a sudden, but as the time went on and we had more opportunity for people to get into a house with new mechanisms for funding, mortgages, lending practices, new technologies to get everybody into a mortgage, risky loan geographies were created slowly over time. And for which, when the bottom dropped out suddenly in the market, those risky loan geographies that got created suddenly became geographies of foreclosures. So the negative values of foreclosed properties transfer to other nearby properties, and these start to spread. And as those go into decline, neighborhoods can degrade and become socially and economically reshaped for worse, and lead to other social problems that can emerge. So I think it might be, clear that local leaders have a reason to keep an eye on the pace at which foreclosures are occurring and to see if they're occurring in space and time to try to target their efforts to prevent these from happening. And we'll talk a little bit about some of those policy options towards the end. So in Charlotte, North Carolina, we selected this for a number of reasons. One was a convenience sample. We had a very rich data set, but it was also, amongst the data sets that we had, a jurisdiction that did not have an over or hyperinflated market that, unlike a lot of places across the United States and Florida, the Southwest United States, and up in the Northeast. And what this does is this allows us to test the near repeat approach in a regular environment to see if it does indeed work. If it does, then we have an opportunity to try it in the places where it is really severe to make sure that we are not testing it in a place where it will work only when it is severe. Because everybody could benefit from this by watching their housing market and making sure that their investments in their communities don't deteriorate. So as we can see here with Charlotte and Mecklenburg, the price distribution was such that a lot of places were very affordable in the Charlotte-Mecklenburg area. The median house price was $107,000, and with the flexible loan packages out there and the multiple opportunities to get into a mortgage, we had there was a lot of opportunity for people to afford to buy a house in the area. And so these are the four types of housing that we are going to look at in the near repeat analysis, because all of them can go into foreclosure and become part of our data set. So if we just look at foreclosure rate across Charlotte and Mecklenburg at the census tract level, which is typically done when analyzing things with Geographic Information Systems, and we can see that, we have a particular crescent pattern that encompasses the city from the northwest down to the southeast, with some down to the southwest there. And we can see, various levels of foreclosure rates across there, with a few census tracts that were really hit hard, where some were in the middle. However, given that we're using an aerial unit, what gets lost in there is where exactly these foreclosures were occurring. In any one of those census tracts, foreclosures could be spreading across all of them. It could be in one small part of them. But with the actual foreclosures and using the near repeat approach, we can see where those clusters of foreclosures are occurring specifically and to what rate. So here's the near repeat output that comes out of the near repeat calculator. So you get the contingency table that shows the specific distances that I used for this analysis. So on the top, you see here a contingency table that shows the same so the intervals of 30 days, and we selected 30 days because the foreclosure process happens in an administrative cycle that usually takes place on a monthly basis. Your first notice, second notice, third notice, procedures are initiated, steps are taken legally, and so forth. And the distance interval was created by doing a nearest neighbor analysis to identify the average distance between any one of the foreclosures. And 660 feet, which is about 1/8 of a mile and just shy of a city block, is our distance interval. And as you can see, it goes out to 5,280 feet, which is a mile. Now what you see across there at the bottom, what you see is the significance level for each one of those cells where you have a measurement taking place. So how you interpret this is that at the same location, which would likely be condominiums or multifamily houses where the foreclosure is recorded at the same address, you have a 1,245% likelihood another foreclosure will occur at the same location with a p-value of 0.01. This means that there is a high likelihood that this was not due to chance, and that there is across this contingency table, places that have multiple units in them share the largest amount of likelihood of going into foreclosure. So as a local official, we might want to take a look at all of the properties across the area and try to find out what it is about these particular places, and maybe focus education efforts, to focus relief efforts to try to keep families in their home or stem that particular tide. So if we take a look at another one at 31 to 60 days out at 1,660 feet, we see there's only a 22% likelihood another foreclosure will occur within 660 feet of an originator, again with a p-value that is really high, suggesting that this is not due to chance. So as you can see, across this contingency table, there is some distance decay where at the closer they are, the higher the likelihood, and it starts to drop in a decaying pattern. Same way with temporal decay, where we see that we have a high likelihood at 30 days from your original one that spread decreases as time goes on. And we can see different patterns within here that allow us to say, well, what is it about these particular patterns that we're seeing? At 91 to 120 days, you're seeing a good likelihood of foreclosures occurring across most distance intervals. Now 91 to 120 days is about when the notices have rolled out and foreclosure actions are starting to take place. And then you can see them roll on from there. So this gives us some indication of where we might look in the process as far as where people might be at with the foreclosures and how fast they're occurring, as well as at what particular distances, and understand how far and how fast foreclosures are spreading. Now we can map these out. So the near repeat calculator outputs a number or a set of observations with the number of times an event is an originator, as well as it is a near repeat. And so if we overlay that and thematically map it to show the originator to near repeat ratio over top of the average foreclosure rate, we can see that we now have more detail about where these foreclosures were occurring and where they were spreading. So the larger the circle and the darker the color, that means that there is a stronger relationship between foreclosures that are affecting foreclosures nearby. So where you would see those dark circles would be the places where there was a stronger influence and where there was more occurring in those particular areas. Now there are a lot there, but this does give you a starting point, and it can show you that even in some places where there didn't seem to be a high foreclosure rate, there were a lot of near repeats. So we've improved our insight into the distribution of foreclosures as well as in space, but not only in time. So we're not just limited to analyzing data in a bulk form where you have one cut of the data and you just have to stick with that. Because the near repeat process examines the distribution of events in time, it is virtually limitless on how you can split the data up to analyze. So there are a number of ways of doing it with foreclosures. For example, you could go by house or property characteristics, where you extract out certain house types or property types. You can take out the number of the foreclosures by a certain loan type, a borrower characteristic, or some neighborhood or structural feature that allows you to analyze them across specific geographies. So by housing type, for example, here are some differences just to look between newly built and old built properties. One of the things that we noticed in the data was that we saw that there was a huge increase in foreclosures for properties that were newly built from 1995 against those that were built prior to 1995. So we decided to split the data up by that and take a look at that. And what we can see is quite a bit of difference. In Table 4 up here, you can see the near repeat foreclosures for houses built prior to 1995. You can see at the same location there was a high likelihood, but the spatial spread and temporal spread of it was not very far. It was only from about 1 to about a quarter of a mile, and only went out to about 90 days. For those houses that were built post-1995 or 1994, you can see that the temporal spread was much, much further out, and the spatial spread was out to about a third of a mile, slightly more, where you had a few more incidences of near repeats out further spatial intervals and whatnot. So this is clearly showing a pattern that the near repeats of newer properties are more extensive and longer lasting than, oops, forgot that, than the houses built prior to it. So the newer built properties are being affected much, much more than the older properties. Well, let's take a look at it by neighborhood type then. It was often believed that minorities and people of lower income were most of the victims of mortgage fraud, predatory lending, got pushed into loans that they could not afford. So we decided to take a look at that too. So in Table 6 we see foreclosures that occurred in neighborhoods or block groups that had a form of concentrated disadvantage. This is where poverty concentrates, where there's little opportunity. People have skills sets and job opportunities and various other socioeconomic characteristics that put them at disadvantage for climbing the economic ladder. In Table 7, it is for those not in not disadvantaged blocks. And so what we can see right off the bat is that there is a much, much, much higher likelihood of foreclosures occurring at the same location in places in concentrated disadvantage than those that were not. These were likely multifamily complexes where a lot of low-income populations were housed, as opposed to affluent block groups where there were less of those types of housing, but there were still something like condominiums where foreclosures could occur. And this would prompt an examination into this to identify where those particular places were. So with the near repeat calculator, we could select out just those same locations within 30 days for both of these to examine where these are particularly occurring to focus our efforts, whether it be investigative efforts for mortgage fraud or predatory lending, or for outreach to try to help people stay in their homes by consolidating loans, things of that nature. We can also see that the spread is very similar, though, when it comes to the time intervals and the space intervals across the contingency table. And it's showing that they're very, very similar, and that most of the people who are being affected by neighborhood type comes down to the same location. So here's what we can do with this to try to focus on some of those places. So what I did was, as I was back at this contingency table, I selected out all of the observations that were within these blocks here as just an example. So here we have an originator to near repeat ratio broken up by standard deviation to show all those places that had a high number of near repeats to an originator to the number that were a low number of near repeats to an originator. So the red ones show a higher influence of an originator where a number of near repeats occurred, where the blue ones represent an originator that didn't have much influence. So this allows us to focus on efforts of where the biggest spread and concentration would be if we were needing to try to mitigate the spread of foreclosures in these particular areas. And as we can see, that there is not much in the way of the largest spread of near repeat foreclosures in areas of concentrated disadvantage, much like our contingency table showed us. Our contingency table showed us that most of them were in the same location, where those ones here that are spatially spread out, we see a pattern where they're mostly out in areas where there are low concentrated disadvantage, but where there are moderate to low levels of high concentrated disadvantage. So it kind of dispels that myth, at least in Charlotte and Mecklenburg, where the foreclosures were occurring predominantly in neighborhoods with low income or impoverished populations. So we can take this a step further, and if we start thinking about this from an investigative strategy, we can start thinking about how we might analyze this further. So if we take the spatial decay of the Knox indexes that were produced in the tables, we can get an idea of how far that spatial dependence falls off to set parameters for further analysis for investigation. So as we can see, foreclosures in tracts with higher concentrated disadvantage started off much more concentrated and dropped off more rapidly than foreclosures that occurred in low concentrated disadvantaged block groups. Although they both bottomed out at about the same distance when it came to spatial dependence. So this is where there's a strong spatial relationship up to this point where both of these curves flatten out here. This is where the relationship between two observations likely ceases, and that measuring anything further out there is likely not related to any of the events that have been measured here. So we can use that to set kernel density or density surface parameters to get an idea of how big to search for foreclosures that are related to create these hot spots and cold spots of foreclosures. In this case, we're measuring for hot spots, though, and we did it in a way that uses what's called a dual kernel density analysis that examines two different distributions at the same time and puts them together so that you can examine them simultaneously in relation with each other. And what we see in the dark red and yellow are foreclosures that concentrated in more disadvantaged neighborhoods and foreclosures that concentrated in less disadvantaged neighborhoods. And these settings kind of reflect the distance decay curves that we saw where the orange and red, you see more red than we do orange, which represents that steeper decay curve. But in more affluent neighborhoods, we see more of the green and the light blue than the dark blue, representing that less steep curve that we saw there. Now what we can do with these is focus our efforts more than just what the graduated circles show. This gives us an area for which to focus efforts. In particular, when examining for mortgage fraud and predatory lending, this gives us a new sampling space to use to try to truly identify where mortgage loans that were susceptible to mortgage fraud for further investigation. Because if you just randomly selected without knowing where to oversample for where concentrated foreclosures occurred, then you might be missing some just because you didn't sample properly to identify them in relation to each other. So this gives an opportunity to go in and sample in these areas in such a way as to make sure that you get enough of a representative sample because of the large amounts of events that had occurred there. So as I was saying, that so fraud is not apparent sometimes in tabular data or other graphics, and so because it's unusual for high concentrations of sales foreclosures, this allows us to focus attention on certain areas. So as I said, it allows us to properly sample in areas identified based on space and time, because that is not what should be occurring given our principles of why foreclosures occur in the first place. So what we did is we took this a little bit further for an investigative strategy working on a mortgage fraud case, where we were looking in Charlotte-Mecklenburg, where we were using another tool, Cluster Seer, which takes the Knox test and actually creates links between all of those properties, all those events that were in space and time. So using the distance decay identified in the near repeat calculator, we identified all those foreclosures that occurred within a specific space and time, and we identified those with links. So we went in and we looked at one particular set in a neighborhood to look for, so this is a cluster of links in a set of properties in Charlotte-Mecklenburg, where we're looking at off to the left here, the whole group, but now we've whittled it down to just a small number of parcels to look at for commonalities. And we did find some commonalities. If we look over here to the right, we see all these properties that are in relation to this one particular property here. So we have Jacobson properties linked in time and space. And what you see here is the names of a couple that keep reappearing with these properties as time goes on, both pre and post, when the property at Windy Lane went into foreclosure. And this now gives us an indication that there is something with these particular properties that might be worth investigating, because Mitch and Kate Mitch and Kate, Jack and Cindy, all ending with the name of Jacobson, all within the same neighborhood and within close periods of time, went into foreclosure on numerous occasions. So had we not done a spatial analysis, this might not have been picked up as easy, if at all, had we not had some focus to put our attention to that particular neighborhood. But beyond mortgage fraud, there's a number of things that can be used for help. Near repeat analysis can be used for local officials. So monitoring future events. It focuses attention on areas where mitigation and investigation are needed, if we're looking at it from a law enforcement perspective or a prosecutorial perspective. It identifies neighborhoods with the greatest risk for economic decline, might want to send resources into those neighborhoods, develop strategies to deal with the fallout and the economic decline, whether it be deal with the property owners who own those places or upkeep or maintenance by city maintenance services. But the important thing is that temporal aspects can now be considered. It's not just where the concentrations are, but which ones are spreading and how fast, because that might want to take your attention. If there's a particular neighborhood that you're seeing a lot of near repeat events and there's a high amount of them and they're moving fast, you might want to triage to deal with those particular properties with a number of mechanisms available to city officials. And so, you know, we've talked about all these other ones leading to investigation and underlying link for prosecutions, because one of the things that mortgage fraud and geographical analysis has been doing is help to build the case for prosecuting offenders, white-collar offenders who are committing these white-collar crimes. It is often believed that white-collar crimes are victimless because nobody really gets physically hurt. But these crimes, when they cause neighborhoods to fall into disrepair and social problems emerge, people's lives can be devastated in a number of ways, not only in the loss of money, but in the loss of their homes and opportunities to make their lives better. But if social problems emerge, people can get damaged from those in a number of ways. And so these are being used as examples to strengthen the case for prosecutions, to strengthen sentences to criminals, as well as increase the sanction levels to really make the punishment fit the crime for the amount of damages that it can do. So our final example, which is going to be measuring voucher concentration in Dallas, Texas. So our near repeat expectation here is that it would not be expected that relocations by a similar population would occur in close proximity to each other in short periods of time. So the idea is that when people get a chance to move, it is due to some life change events again, to which they've gotten a promotion, they've got an opportunity to get out of their neighborhood, changes in family structure lead people at different times to move to different places based on what they can afford and the opportunity structure of the urban environment that allows for purchasing a house, renting, or leasing, what have you, that you would expect people to not move into the same neighborhoods in space and time closely together. So there are three non-mutually exclusive reasons here of why we would expect near repeats, though, is that there is a limited supply of affordable housing. So for people on the lower income ladder who have to use vouchers to move to other locations, there's a limited supply of affordable housing out there. So this whittles it down to a few places where they can move, especially in urban areas where there is gentrification going on and the city is economically becoming more viable and more wealthy. There is a limited number of landlords who are willing to accept vouchers even in places where there are affordable housing, but also voucher holders like to live near family, social or other resource networks that they know and are comfortable with to stay connected and not feel so isolated when they do relocate. So we do have some reasons for believing that there would be a near repeat expectation with this particular population. But what are our concerns, though, with near repeat vouchers? Well, poverty-related problems might emerge. One of the reasons why vouchers are being used is to deconcentrate poverty, to allow people on the lower economic rungs of the ladder to move out to other neighborhoods and get better opportunities. If those things emerge, social organization might weaken, leading to deteriorated living conditions in which they lose political capital, nobody's paying attention to them, and things get worse. And as that kind of occurs, economic disinvestment may occur, leading to lesser business types and other resources that voucher holders may need in these particular areas. Landlords might extract higher rents because of fewer non-voucher properties, so they see the opportunity to try to take advantage of that steady income and extract higher rents from these particular places because there's fewer properties to compare against. But landlords might also maximize profits for foregoing maintenance on voucher properties because they know they have that steady income. Voucher holders have less likelihood to have political capital to make a fuss about it and organize and make them do something about it. So we do have some concerns with this and why we want to pay attention to whether or not voucher holders are concentrating and to what rate in any particular neighborhood. So again, our near repeat output for voucher holders in Dallas, Texas, again we see that we use 30 days because voucher processes and moving processes again sort of occur on 30-day cycles, whether it be times of notices, times to process paperwork, and whatnot. So we used, again, 30 days as our interval. But our nearest neighbor analysis identified a different distance to which 1,760 feet is our average nearest neighbor between voucher holders between this time frame, which is, by the way, between 2009 and 2011. And we are only looking at new voucher holders. So these are not people who have vouchers already. These are new voucher holders coming into the program for which they are using their voucher to relocate. So as we can see, we have an extensive pattern here spatially. And Dallas is a very large area. So we can still, again, see that distance decay where at the same location, there's a higher likelihood of voucher holders to move in within the 30 days of the first voucher holder that moved in. And it slowly decays, and it quickly decays over time, as well as space. But we can see this pattern is quite extensive, and this is kind of reflective of the limited supply of neighborhoods for which voucher holders have the opportunity to move into. Now, because it got truncated down here in the end, we might want to go back and expand the near repeat parameters to allow more distances or combine these distances together because they might be too fine. But for now, we're just going to take a look at this. We see the patterns there. We see a strong likelihood that they are concentrating in these particular places, not due to chance. So if we look at our distance and time decays from those, we can see two particular things. We can see that our temporal decay reveals that new emissions relocate in each other early on, but gradually less so at earlier dates. This kind of indicates a steady process over time for which more people seem to be moving in shortly after other voucher holders have moved into these particular places. But when it comes to spatial, we can see that they are moving into very, very, very concentrated places and at a steady pace. So this indicates that there is a very limited supply of neighborhoods where they are moving to, or they're trying to stay together for social, economic, or resource reasons. But this is a continuing process for which people are moving from an original voucher relocation shortly thereafter up to about 180 days, for which it pretty much drops off. So again, we look at the near repeat ratios across the Arlington, Fort Worth, and Dallas area. This is the neighboring area for which was not part of this analysis, but has some pretty good patterns to show what this can look like. And it looks a bit kind of a mess in some ways, but what's important is that you can see the places that had the high near repeat to originator ratio, where you can see the dark black circles show where the most influential originators were. So these could be places where there are high-rise communities, where there's dense clustering of affordable housing, for which these are the places where there was the greatest influence, for which more near repeats occurred close by. And if you can see the white circles, this does kind of show that particular effort, where you can see some clusters of originators together, but a lot of times you see here was the strongest, and over here in south of Arlington, here was a really strong originator. Once that relocation occurred, there was a lot of near repeats to follow real closely afterwards. And so these are the places that we might focus our attention. Now, we can again do the density surfaces, but we can take the near repeats, take the observations and weight them by their near repeat ratios to get the idea of where the greatest density is occurring based on that ratio. And if we look over here in Arlington, we saw that particular pattern where there was that one near repeat originator that had a lot of near repeat influences. But the interesting thing here is up here north of Dallas and here to the west of downtown Dallas, you see a high density of near repeats occurring here and a high density of near repeats occurring here. What these are high-rise complexes where people are moving into high-rise complex, and they're not really spreading out, but they are moving into one of several buildings in these particular areas, or several complexes at the same address is occurring. Here it's a little bit more spread out where you can't really see because the number of near repeats covers it, but there are a real strong influencing properties underneath there. But the interesting thing is that you don't see a spread here. They're really highly concentrated. Here they're kind of spread out, but they're still kind of concentrated in certain areas. So what are our policy extensions from this? Well, we can use to measure and monitor voucher deconcentration plans. All PHAs have a deconcentration plan for which they have to monitor to make sure that they are doing their best and whatever they can to try to make sure that people who are in public housing assistance are deconcentrating from neighborhoods where they're currently living, but also to make sure that reconcentration doesn't occur for the same reasons that we mentioned earlier. But also focuses attention on neighborhoods where social services might be needed. If, in fact, concentration is starting to occur, these are people who do need help in various ways to try to make ends meet, to try to get ahead, to try to find jobs, to find resources, daycare, things of that nature. But this can also lead to analyzing demographic or economic conditions for reasons why. If we know that people are moving into the same neighborhoods and at a rapid pace, it gives us the opportunity to do surveys and find out, well, what was the draw to this neighborhood? Where did you come from? Why did you come here? As ways to understanding the mobility process, which is something that's emerging in both policy and research today, is to understanding why people are moving where they are, so that we can try to craft better policy and really truly help them make the best mobility decisions that they can find. But also can focus on landlord outreach. One of the keys to this is identifying landlords who are willing to rent to voucher holders, as well as providing opportunities to make sure that the landlords are meeting the needs of the voucher holders as far as conditions of living. But also, you know, if you have an idea of where voucher holders are moving and concentrating, you can help other voucher holders relocate and make more informed choices by seeing where the concentrations are occurring, where they're not occurring, where there are other opportunities that they move so that deconcentration does not occur and social problems may remanifest themselves. So that's two particular examples of how to use near repeat analysis. So I'm going to, I guess, open it up to questions now.
Well, thank you very much, Ron, for a great presentation. Excuse me. We've got a few questions here, and let's see. I'll start off with kind of, I guess, the extensibility of this kind of research. The prior UMBC webinar that we heard discussed big social data. Do you see applications of near repeat analysis in that particular area?
Yes, because what the near repeat calculator can do is it can summarize data into smaller units of analysis for focusing in a couple of ways. So you have an enormous data set. If you set space and time parameters to be at certain levels, it will search through that data set and find all the incidences that are related in space and time and summarize them into a location as represented by a near repeat ratio. So from there, any one of the cells that you saw in the contingency table can be selected out for focus. So if I used any one of the spatial intervals that are close, at 0 to 30 days or 1 to 660 feet, or go out to 5,280 feet to the next quarter of a mile, all the way out to some time interval to 90 to 120 days, you can focus on those based on what the contingency table tells you and just summarize it to those and analyze just those.
Oh, excellent. Now, I guess one of the fundamental issues with this kind of analysis is having the data. Are you aware of other good publicly available data sets that have the right kind of information, temporal data, thematically, etc.?
Well, most of the data, I think, are going to come from local sources because they're the ones collecting data to this level of detail. Most of the time when you get into national level data sets, they aren't capturing this level of detail. That makes it kind of difficult to follow through. Now, there are some data sets out there, like if somebody wanted to analyze foreclosures, they could probably turn to RealtyTrack and purchase some of their data, if not all of it, for which they could apply the same thing. So there's an example that kind of goes back to your original set. You have an enormous data set, a big data set, for which that you could set this in motion. Now, I do have to say there's one limitation of the near repeat calculator where you would have to carve that data up into small chunks because of the memory management. It can only handle up to umpteen thousand records based on the memory limits in your computer. So the more memory you have, the more that you can crunch, but still it's limited because it uses a n-by-n contingency table. But so local data sets, though, usually are have records that the near repeat calculator can manage.
One question here is, are there courses in the UMBC program that might utilize this kind of analysis or these kinds of data sets?
Well, there are a couple. As you know, that there's a seminar we're planning for doing on space-time where we're doing the near repeat calculator, as well as some other space-time near repeat approaches that are not just the near repeat calculator. But we also touch a little bit on this in the spatial statistics class as well.
Let's see, question here. Can near repeat analysis be applied to virtual geographies like cyberspace?
Well, I don't see why not. If you have a way of measuring something in cyberspace that has on some Cartesian plane, and those events occur in time and space, I don't see why not. I mean, we do know that in cyberspace that neighbors do not necessarily follow the traditional Cartesian plane, for which those things that are closer are always the most related. In cyberspace, because of high volumes of activity, two places that are far away might actually be closer to each other just because of that volume of activity. You would have to code the data that way, and I think it would be, you'd have to work with it. I'm not sure the near repeat calculator could handle that unless you coded the coordinates to be in such a way as to represent each other. But as long as you can represent cyberspace in a pair of coordinates with a date stamp, I don't see why you wouldn't be able to do that.
What other government problems could this kind of analysis be applied to?
Well, one that I can think of are traffic crashes. Those occur with relative frequency, and I do know, as a local data set, most metropolitan areas do in fact capture traffic crash data quite well, with a lot of detail. So if you have an instance where you're seeing a lot of crashes occur in the same area within short periods of time, that is an indicator that something has occurred in that particular area, or something is wrong in that particular area. So, for example, if you didn't see a near repeat happening before, but then suddenly there's an originator, and there are more near repeats to follow. Code enforcement could be sent out, or building inspectors or infrastructure planners could be sent out to examine the area to see what changes that took place. That might have been something like, a new bike share program where a set of bicycles were put up there where they're causing traffic to change its patterns, or people can't see coming around the corner because there's so many people there with bikes or what have you, for them to try to identify what might be the problem. In some cases it might be structural, where you'll see just an ongoing near repeat cycle over and over and over again.
Do you think there's an application perhaps in like health-related, medical, I don't know, even like epidemiology, something like that?
Oh yeah, and that's a natural one, because a lot of this is based on sort of that contagion effect, where for vouchers we were looking for sort of this infill, but a lot of times in epidemiology you see that you're looking for this contagion effect. So if you had locations of people that had some particular virus or disease, and you had that particular address, and we recorded when they visited the hospital, or when they first reported their particular systems, this could be used for detecting the emergence of some viral strain or other related disease.
Well, very good. Well, Ron, I think that's going to wrap it up for today's webinar. I want to thank you very much for giving us this presentation. I want to thank everybody for joining us here. We do hold these periodically every few months or so. Our next one will be sometime in the early spring, I believe, and just stay tuned. We'll be sending out notifications on that. Ron, thank you very much.